And welcome back, and it is the Further Maths 5-a-day for the 23rd of Feb. And let's go straight into the first question, which looks like, oh actually no, I thought it was going to be a solve. It's not, it's just a single fraction. So what it wants me to do here is it wants me to have a common denominator. Now I've got 4x cubed, 3x, and well, it's over 1, isn't it? It's because there's kind of like a hidden over 1 there. So I'm going to make my common denominator. I'm going to do this all in one go. You're watching a Further Maths video. I'm going to presume your maths is fairly good. So I'll make my common denominator 12x cubed. What do I do to the first one? Well, I need to multiply that by 3 to give me 12x cubed, which means the 9 becomes the 27. So I've done that one. What do I do to the second one? Well, it's 3x, and I want 12x cubed, so I'm going to multiply by 4x squared, which is going to give me 20x squared. And on this one over here, well, I don't have anything, so I'm going to multiply x squared by 12x cubed, and that's going to give me minus, be careful of this minus here, that's going to give me minus 12, what am I doing, 12x cubed times x squared, 12x5. So writing it outside of the margin so you can actually read it slightly better, that gives me, order doesn't matter here, but I'm going to write it in the same order I'm given, 27 plus 20x squared minus 12x to the power of 5, all over 12x cubed. And that's the first question done. Nice little sort of simple algebraic fractions question to get us going. Right, and we have another simultaneous equations question. If you've seen in my previous videos, you know I'm not great at these. I tend to miss the thing I'm supposed to spot. It doesn't matter because it just means I'm doing the algebra, but sometimes luck just happens to have gone my way. I would notice that I've got x, x and 3x, so it would seem easier just to concentrate on the x's first. So let's just do, because it's ready to go, let's do equation 1 minus equation 2. So x minus x goes away, minus y is minus 2y, 3z minus 6z is minus 3z, I should have done this the other way around, shouldn't I? And 5 minus 12 is minus 7. Now I'm just going to do something cheeky here and just multiply everything by 1 minus 1, which is going to give me 2y plus 3z equals 7. I can do that as long as I'm being consistent. Not bad. Then I'm going to make, what should I do? I'll do equation 1 times 3. So 3 times equation 1 is going to give me 3x minus 3y plus 9z is equal to 15. Then I'm going to write equation 3 underneath it. Actually, I've written that wrong. That should be 3 times equation 1. So that's 3 times equation 1. And then equation 3 underneath is going to give me 3x minus 2y plus 2z is equal to 10. And then I'm just going to take these equations away. So take them away. So minus 3 minus minus 2 is minus y. 9 minus 2 is plus 7z. And 15 minus 10 is 5. And that's given me, let's label them over here, it's given me equation A and equation B. Now, I haven't got anything that's the same here, have I? So let's write down equation A here. So equation A is 2y plus 3z is equal to 7. That's why you have to be careful you're writing, so that was a 17. And then I'm going to do 2 times B, which is going to give me minus 2y plus 14z is equal to 10. And then I'm going to add these equations up. So 3 and 14 is 17z. 10 and 7, thankfully, is 17, because I was worried I was going to get some really horrible fraction, which means that z, finally I've got there, is equal to 1. Let's put this back into, let's do equation A, and that will find out what y is. So equation A tells me that 2y plus 3z, I know z is 1, so I'll just say plus 3 is equal to 7. That 7 does look like a 17, doesn't it? I'm going to get rid of the plus just in case I do that again. Take away 3 from both sides, which gives me 2y equals 4, which means that y is equal to 2. So I've got my z, I've got my y. Let's go all the way back to equation 1. And so equation 1 says x minus 2, which is y, plus 3 times z, which is 3, because z is 1, is equal to 5, which means x plus 1 is equal to 5, which means x is equal to 4. There we go. What was quite nice about that is it didn't fall out neatly like the last few have. You actually had to do a couple of simultaneous equations there, which actually I think makes it a slightly better question. Either way, x is 4, y is 2, z is 1. Well done if you got that. Next question. We've got 2 more questions. Usually we only get 4. Right, next question. Y equals x to the power of 4 minus 2x squared. Work out the value of d2y dx squared when x equals minus 5. So it's telling me to differentiate twice and put the value in. So let's do that first. So first of all, dy dx is equal to 4x cubed minus 4x. Then I'm going to differentiate again to find out d2y dx squared, which is equal to 12x squared minus 4. And then it wants to know the value at x equals minus 5, which is going to give me 12 times minus 5 squared, which is 25. It's going to be a big number. Minus 4 is equal to, well, 12 times 25 minus 4 is 296. And that is question done. On to the last question. Right, we have approved that. Okay. I'm laughing because we had one like this a few days ago. It's a bit of a classic question. I really like this question. Even if you just watch me do the maths and you sort of watch along and enjoy watching maths, which is fine because so do I, pause the video and have a go at this one anyway. I think it's a great understanding question. Did we manage to get it? The way of doing this is you need to remember that n cubed minus n is the same as n times n squared minus 1, which is the same as n times n minus 1, n plus 1. So far, so good. Then I would know that I could write this as n minus 1 times n plus 1. And you might be thinking, so what? Well, the important thing is that this is 3 consecutive integers. So this is 3 consecutive integers. So if you think about anywhere on a number line, pick any random number, 212, no, 211, 212, 213. It is impossible for one of these numbers not to divide by 3. So in other words, if you have 3 consecutive numbers, it must divide by 3. So therefore it must, don't know why the pen is so thick, but anyway, it must divide by 3. It is also the case that because I have 3 consecutive integers, at least one must be even, which means it must also divide by 2. Now, if a number divides by 3 and divides by 2, it implies it divides by 6. Isn't that a clever proof? It's really, if you haven't seen that before, really nice thing to see. Once you've seen it, you will remember it, and it'll be one of those things that you remember, and hopefully it doesn't come up in your exam, but it's a nice thing anyway. It will come up at A-level, by the way, so it's one of those things that comes up every now and then. Either way, hopefully you enjoyed today's questions. I thought it was a nice mix today. Do, as ever, like and subscribe to the video. Let me know how you did in the comments. I do like reading that, and I'll see you for the next one. Thanks all.